So this is the exciting bit now. This is where we get to cut the hole out bigger than it is. This is sitting at just under 50 millimeters, and our fork leg is just slightly under 53. So we've got 3 millimeters of diameter to come out of here. And what I'm going to be using, this this boring head here. And what I've done is I've set the tool up now. And what I've done is I've just put a little bit of back rake on the tool there, just to give a little bit of clearance. And as you can see that these graduations, this is actually a imperial boring head, and each graduation on this little scale here is 1/1000th of an inch. What we've got to remember is that if we dial in, let's say 5/1000ths, what we're actually doing is we're taking 10/1000ths, or we're taking around about 0.2 of a millimeter out. So so that's something that we've got to consider. But what I'm going to do now is I'm going to get this mounted in the machine, and then what we'll do then is we'll take a little scratch cut here just to get the 0 point, and then we can maybe dial in, I don't know, maybe 5/1000ths, which will take a 10th cut, and we'll just send the machine in, and what we'll do is we'll just cut it out, and we'll see where we go from there. What I'm aiming for here is I'm aiming for 53 millimeters across there, which should slide on to the fork leg. And of course we've got this little bit of movement here where it clamps. And then what we'll do then is once we cut this hole out to 53, then we'll move back to the origin. And this is where we originally set the machine up. And so we can, on the DRO, we'll get the origin back, and then we'll come back to this point, and then we'll cut this out as well. And that'll be it after that. And hopefully it'll cut okay, and there won't be any serious vibration. I'm going to be running this machine, I think, at 280 RPM. I don't really want to go much more. And I'm going to be using the auto feed on it to feed us into this, and that'll be running at 0.1 of a millimeter per revolution. So we'll be taking, in old money, 0.004 of an inch per revolution as we go in there, and hopefully that should be okay. If we start to get a bit of chatter and a bit of vibration, then we'll just back it out, and then we'll just do it by hand, and maybe even speed it up or slow it down. It's difficult to know how this is going to react, because there is quite an overhang here, as you can see. But we'll get this tool in now, and we'll start cutting. Just going to put a little felt tip pen mark in here, because what I want to do is I want to just make sure that we're taking a little scratch cut when we bring the tool in. And we've got our Allen key there to adjust the tool. And what we're going to be doing is we're going to be moving this out the way. So what we'll do is we'll bring this down now, and we'll just see where we are in relation to the workpiece. Okay, so that's us now touching this now. We can now bring the tool out. think we're a little bit oval here, and I think that's probably because we've pinched this up quite tight against here. So we're taking off a little bit more off this side than we are on here, but I don't think it's much. And I think by the time that we give it another 10 thousandths or so, this will actually bring it into line. Yeah, we're taking a full cut now. It's a nice finish as well. So what we'll do now is we'll just measure this. I just want to make sure that we've got a starting point, and then what we'll do then is we'll start adding in, I think, probably 10 or 15 thousandths at a time. Again, we don't want to overload this. Although the cutting forces are not that high, we don't want to set up any vibration, and we just want to make sure that we get it absolutely right first time. We don't want to be going back and starting to machine it again. So yeah, we'll just continue cutting this, and we'll just keep opening it out fractions of an inch at a time, or fractions of a millimeter at a time, until we get our target 53 millimeters on it. But I'll just get it measured just now, and then we can add some more. Well, I think that's close enough. That says just a fraction under 53 millimeters. So I think we'll call that good at that. And I mean, we've got this, you know, this pinch bolt here. So once we back that off, it should slide over the fork leg okay at that. So we're good to go. So what we're going to do now is go back to the origin on the DRO, and then what we'll do then is we'll machine this out. At least we know now that our jig is working. We know that we're not setting up any massive vibration in here, as long as we keep the cuts quite light. So providing everything, providing nothing's moved, then we should be able to go back to our origin where we originally indicated our hole, and we should be good to go on that. So this is where we get to see how well we've done overall, and I have to say, machining wise it was fine. We didn't have any vibrations, so our little jig here worked pretty well. So I'm pleased with that. That was good. Let's just see now where we are measurement wise, because what we were trying to hit was 53 millimeters on both of these openings. So I'll try to measure this pretty much where I measured it originally, and we'll start with the left one here. And looking at that, we're just pretty much bang on the 53 there. So that's good. And then we'll just try the other one here. .53, spot on. The truth is how it actually fits onto the fork. So that's how it would normally go on. So this is the left-hand one, and that's a nice sliding fit on there. So once that pinch bolt is tightened up, that will have a good fixing on there. We'll try the other one now. And that one just slides on, and there's resistance on that one as well. So that's good. I didn't think it would turn out as well as that. Always the pessimist. The only thing is, just as you can probably see there, we've just actually broken through into. This was my biggest fear when we started doing this. I thought that we were going to break right into these pinch bolt holes here. So this one's all right, but this one has just broken through and no more. Now, either their hole is in a different place than it is on this side, or that maybe we were about 10 thousandths off on centering this up, but I'm not so sure about that. But anyway, I think we'll just work on the principle that the hole wasn't drilled in the right place on this particular one. But there we are. So all in all, it's actually worked out pretty good. So I'm delighted with that, and better get this back to Martin now, and I won't be riding the bike though.